before getting into the weeds of X-ray CT, let me introduce ZEISS in the same way we would do a good CT scan, starting from the big picture or a general overview down to high-resolution details by zooming into the main areas of interest. ZEISS is a company with 178 years old history. We are everywhere in around 50 countries. We have over 46,000 employees. This past fiscal year, we had a revenue in euros of 10.1 billion. And around 50% of that, more than 1.5 billion, were invested in R&D. We have presence in 4 main segments, including the semiconductor manufacturing technology, the industrial quality and research, the one in which I belong, the medical technology, and the very popular consumer markets. If we zoom into industrial quality and research, where I am, we produce optical measuring systems, CMMs, laser scanners, microscopes, and X-ray CT systems. If we further zoom into X-ray, we have a lot of systems that serve all the different markets. And to make life easier for you, we split in 4 main families. The Metrotome family, very popular for metrology or measuring systems. The Volumax, fast speed for inline scanning. The Voxel systems, mainly 2D imaging systems for high resolution. And then we have the X-ray microscopes for very high resolution. And let me then further zoom into the systems that are on the top left. That's my left. Let me check. Yep, that would be right. So if we zoom into that, we have a series of different systems, and I will continue to zoom into one of those. The latest, we have just launched the Versa Excellent 730 over the left, my left. Let's just keep going. I want to highlight, before I go into the Versa Excellent, let's just quickly remember one of the main limitations of the X-ray CT systems, the classical CT systems that are driven by geometrical magnification, is that there are limitations in the resolution when you try to zoom in because of the size of the object. So there is a limitation there, given by the geometry of the architecture. In the X-ray microscopes, what we do is we combine the geometrical magnification with optical magnification by inserting optical lenses that magnify the light that is converted after the X-rays get converted into light, magnify it before it goes into the final CCD detector. And we can use different lenses like a light microscope to further zoom into small areas of interest at high resolution. The plot over there compares how a typical CT works. So you have the decrease of the resolution with the larger working distance driven by the object size. When you have the X-ray microscopes, then you can maintain the resolution even a larger distance for larger objects if you zoom in smaller regions of interest. And this is the typical workflow. We like batteries, everyone is talking about batteries. Well, I cannot just wait to show you how we do batteries here too. And you have images starting from a full field of view with a flat panel scanner, then going to volume 4x, 4x, and 20x down to a particle level scan. So that's what you can do with an X-ray microscope. And now, what is special about the Versa Excellent 730? We have several versions. This is the latest generation, and I will summarize in 3 key attributes. The first, we have a new X-ray detector, the 4X prime, that extend the capabilities of resolution, but generally people specify resolution at a very low kb. This is not true anymore. We can maintain the resolution down to 500 nanometers spatial resolution across the kb spectrum. This is quite important. The other one scan is the combination of a new operating software that we call Navix 2.0 and fast scanning the flat panel. And of course, the introduction of artificial intelligence to do the reconstruction with Deep Recon Pro. This shows you how you can expand now the typical applications that you could access with these X-ray microscopes, because when you have denser materials in electronics or batteries, you need to raise the KB. So this is very important for that. The benefits of the 4X Prime combined with Deep Recon are illustrated here, also for a small pouch battery. And you can see the differences of the particle level detection that you see in this arm. The fact that you now have the ability to put a flat panel scan, detector that can produce fast scans allows you to, in combination with dynamics, go very fast in the workflow to the point that the system, additional to doing this fast, can give you recipes how to optimize the scan. It actually gives you 3 different set of parameters that you can choose for optimize for resolution, speed, or something in between. This is an example of the combination of this operating software with fast mode to scan a coin cell ion battery, and you can see it scans down to 1 minute. Now if you start zooming in, and on top of that add artificial intelligence for reconstruction, you can see this level of detail by going into the small areas of interest. And here is a comparison of what you would obtain when you use the standard reconstruction with more than 3,000 projections, and if you start shooting the projections to speed the scan, what happens, how it degrades with the standard reconstruction or the traditional FDK. But if you use Deep Recon, which uses deep learning training, then you can go down to 400 projections and get a really good quality scan with high quality and good speed throughput. So to summarize the full workflow and how can you take advantage of this is that you have a part, you can put the part in there, you use ZEISS now that guides you through the workflow, even gives you some set of parameters so you don't have to have that mental overload or be an expert to a PhD level to operate this type of systems. Get a quick, fast scan with fast mode, locate a region of interest, again use ZEISS to go into there, and then go to the best detector, the 4X Prime, to get the best resolution, and maybe even use deep learning to do the reconstruction. So this gives you an idea of how you can work with this type of system, and the applications are everywhere, from assembly analysis, electronic inspection, project analysis, part design analysis, even some dimensional measurements, structural assessment in additive manufacturing, aging of batteries, and fiber material characterization. With this, I will try to end reminding you that we have a booth where you can talk a lot about these things. We have a 2-year free license for Deep Recon. We are located upstairs in that corner over there, so don't forget to visit us. And I think this is all from me.